All right, this is 7-4, special right triangles. So far we've had all sorts of different triangles going on. We learned about similar triangles last time. Special right triangles are a particular kinds, there's two of them, of right triangles, which means they have a 90-degree angle. And they are essentially like they have special angles within them, and so because they occur so commonly, we have figured out patterns that happen in these triangles. So first we have the 45, 45, 90 triangles. We just call them by their angles. They have, of course, a 45 degree, and a 90-degree angle. And so it turns out that their side lengths have special relationships if they are these kinds of triangles. So for 45, 45, 90 triangles, the two sides, they're isosceles triangles actually, so the two sides are the same, the two legs of the triangle, and then the hypotenuse is the same angle but multiplied by the square root of 2. And we will see an example of that later. So if we know one of these sides, then in fact if we know any of these sides, we can figure out what the other two are. So very useful in our lives. 45, 45, 90 triangles are fantastic. We like it because they have two of the same sides, so it makes our math a little bit easier. The other option we have here is a 30, 60, 90 triangle. This is also a special right triangle. This is not an isosceles. Technically, it's a right triangle, and it's scalene because it doesn't have any sides same or any angles the same. So this one's a little trickier. The shortest side we've labeled x here. And then from that side, you can get both of these different sides. One of them, the hypotenuse particularly, you multiply by 2 to get that long side. And then this one is weird, but you multiply it by the square root of 3. For a lot of these problems, and I'm not sure how it is on MathSpace, I can't remember, but for a lot of these problems, it's easier to just leave the square root of 3 tacked onto the end instead of actually multiplying and getting a really terrible decimal. So sometimes systems will prefer that. So in our problems, I will get decimals, but I'll also show you that you can put just like whatever value it is and then put root 3 on the end. So this will hopefully make more sense when we start doing practice problems. Number 1 is a 45, 45, 90 triangle, and they have given us one of the side lengths. And referring back to our picture here, the two legs of the triangle are the same. So this and this value, this value and this value should be the same. And then this value is going to be that same value times root 2. That's how all 45, 45, 90 triangles are. So if that side's 3, this side's 3, and this side is 3 root 2. In particular, 3 root 2 is 4.24. But like I said, either of those answers I would take, especially like on a test. I would take either this or this. So both of those are okay with me. So this is a 45, 45, 90 triangle, easy as pie, right? 3, 3, and 3 root 2. That's how all of the triangles are. You just change that base length here to be whatever the shortest side is. So whatever the legs are, they're the same, and then you multiply by root 2 for the hypotenuse. Number 2 is a 30, 60, 90 triangle, and they've given us, helpfully, the shortest side. So if we look at our diagram here, the other leg is going to be this value, but times root 3. So that is going to look like 3 root 3, which that value is like 5.2, but like I said, I would take either of those. And then the hypotenuse is just double that value, so 3 times 2 makes 6. So notice how I'm matching up that value each time I am multiplying by whatever my diagram says I should. to get those other values. So, so easy peasy, right? Now we get into, sometimes you don't have the most convenient side. For example, on number 3, they have given us the hypotenuse of this 45, 45, 90 triangle. And so we know that whatever this is right here, we multiplied by root 2 to get 7, right? So in order to go to the other direction, we have to do 7 divided by root 2. 7 divided by root 2, because we're going the other direction. We're not going from the shortest to the hypotenuse. We're going the other direction. So 7 divided by root 2 is 4.95. So an ugly number, but it's actually the same on both. Once you have one, you have both. So you have to pay attention to which side you're starting with, because sometimes they give you the side that's not quite as convenient. Lovely. Okay, so let's try this. Ooh, too far. Let's try this set of problems here. Number 4. This one is a 30, 60, 90. If you have 30 and you have 90, you know that this side is 60, right? So 30, 60, 90. They have given us the hypotenuse. They've given us the longest side. So we know that this here is whatever the shortest side is multiplied by 2, right? Because this is 2 times something. And I will just write in there that it's got to be 6, right? Because 12 is 2 times 6. So we know that the shortest side has to be 6. We're doing the sort of the opposite thing where we divide by 2, same thing as like the last problem. And now that we have the shortest side, we can multiply that by root 3 to get the other side. So times root 3. So you get 6 root 3, also known as, let's see if I have this decimal. I don't, so we're going to actually leave it like that. You can get a decimal, not too hard, but 6 root 3 is good enough for me. So now we have the same pattern. We have the shortest side times root 3 makes the other leg, and then the shortest side times 2 makes the hypotenuse. Number 5, we have 2 similar triangles. One of them is 45, 45, 90. And the only way I know that is because we have a 90-degree angle here, and then we have 2 of the same angles here, which makes this the only kind of isosceles right triangle, right? There's no other way to get a isosceles right triangle. So we know that those are 45, 45, 90, and maybe I'll indicate that here. 45, 45, 90. So we have 45, 45, 90, and also a 30, 60, 90 over here. On this one, we have the shortest side, which is the best one for us, because that one is the one where you multiply by root 3 to get the longest side. The other leg times root 3. So 7.5 times root 3 is equal to, I'm checking, .5 times the square root of 3, which is 12.99, so super close to 13. I'm getting a decimal because I started with a decimal, but like I said, it's not super hard it's not super bad to just leave it as the 7.5 root 3. Then we have the hypotenuse is twice as big as the shortest side, so 7.5 times 2 is 1415 for this side. And then this is indicating that these two sides are the same. The side of the 45, 45, 90 and the 30, 60, 90. So now we can go from the longest side, the hypotenuse of this 45, 45, 90, and we would have to, in order to go that direction, we have to divide by root 2. Yes. Okay, so we are taking 15 and we divide by the square root of 2. I will actually write that over here. So it's 15 divided by the square root of 2 is 10.6. And both of these sides are the same. So also here is 10.6. Lovely. Okay. Here's one. The area of a 45, 45, 90 triangle is 25 units squared. So this is like a new kind of question here. The area of a triangle, I will write this, is base times height divided by 2 equals the area of the triangle. In a 45, 45, 90 triangle, the base and the height are both the same, right? We have x and x. So this formula starts looking like x times x divided by 2 equals the area. X times x makes x squared. And then we have 25 over here. 25 units, yes. So the way that we would solve this is just algebraically. We would multiply by 2 on both sides. That cancels. Then we get 50 on that side. And then we have x squared. Then we can square root both sides. And that gives us the square root of 50 as the value of x. And that's the best we can do here. Unless we want to get a decimal, x is equal to the square root of 50. So we just use a little bit of area logic to figure out that one. Last one, number 7, we have a 45, 45, 90 and a 30, 60, 90 that share one of their sides. And so the 45, 45, 90 triangle is the easiest here because this is matching 4 and 4 for the legs. And then we would multiply by root 3 for this side. Root 2. I have that wrong in my notes. That is wrong down below, just FYI. In fact, actually, I think there was a wrong thing up here too. So just be aware that these are the correct ones. Okay, so we multiply by root 2. I'm not going to get a decimal because I don't want to. This one, we multiply by 2 to get the hypotenuse, which is 8. And we multiply by root 3 to get this one. That's also wrong in the notes. Keep missing. I mess up my root 3s and my root 2s on the notes. So, and that's all. That's all that we needed is all those sides of the triangles.